So just to introduce our next speaker, Chris Twinn, he is actually going to hopefully bring us down to earth and give us a little bit of an industry perspective. With 18 years experience working in industry, particularly one of the most important parts of sustainable manufacturing is buildings. And how do we integrate technologies like some of the exploratory ideas that we heard about in terms of including solar cells, smart homes, these sort of things. How do we encourage building industries and various communities to uptake that? So I'm looking forward to hearing this. Take the floor, Chris, and let's welcome our speaker.
My background's architecture and engineering. So yes, quite a few decades in the construction industry. And after 28 years, yes, with O'Varant & Partners, so a very large, multidisciplined engineering company, I've spun myself out. You get to a certain point and you realize the corporate has a certain objective, but you're looking 1-2 steps ahead of that. So the idea of being able to feed off and then build on that is where I'm going. And fundamentally, after 25 years of nice clients saying, yeah, you can spend some extra money to make this building zero carbon or whatever sustainable, we should now know how to make it cost no more than business as usual. So the whole premise behind where I'm going is sustainability should cost less than business as usual. I'm going to run through why change, the opportunities, piecing together the bits, institutional legacy, integrated solutions approach, possibly not in that order, but that's looking at the construction industry. Why is it important? Well, actually, it's a bloody primitive industry, but that's the opportunity. It has so much to improve on. These are projects across the world, ones, anyway, yeah. I was fortunate to spend 3 years working out of Shanghai, and it was very interesting. They wanted the latest thinking, eco-cities, and so forth and so on. And you began to then start to dig a little bit further to understand what we were selling them. And actually, you look at this is eco-footprinting curve, and it shows various countries. There's the US on the left-hand side, using effectively 3 or 4 planets, the UK somewhere in there, and China, little more than 1 planet's worth of resource. The snag is the West has done a bloody good job of selling a 3-planet lifestyle to the Chinese. There we are, 20% of the planet consuming 80% of the resources, and we've just convinced the other 80% that they also want that. And you see it all over the place. You can see how they strive for what we've got, and their objective is to get that without realizing some of the downsides we're now noticing ourselves. So that gives you very much a platform for beginning to say, are we doing things right? How could we do things differently? This is the curve that actually I find most concerning. This effectively says the combined GDP buying power of the emerging and developing world is about to eclipse the buying power of the developed world. So our ability to buy that 80% of resource is about to disappear. We have got so used to using resource, it's going to be bloody difficult for us to change. But the interesting thing is the implication behind that. If you build a building, there's a certain amount that goes on materials and stuff to go into it, and a certain amount on labor. What we're finding is the amount left for paying for the labor, which ultimately is local prosperity, whether it's through taxes or what you buy or standards of living, is going down as a proportion of the total. We're beginning to find already the buying power of China as they buy up half of Africa. The Indians, those of you who may be in the industry, are aware that Tata Steel, Indian corporate, has bought up most of European steel manufacturers and is now retrenching back to China, because, India, because they know that's their future market. We are now going to end up paying quite a premium for steel, for example. I'm not going to go through this in detail, but the top bit of that lower graph is constructions as a proportion of world material use. You then break that down, and you can begin to understand how much is going in waste. And then you start to break that down to identify targets within the built environment to reduce our overall impact. Some of the work one started doing in China was actually saying, with a little bit of innovation, we can dramatically reduce the size of kit, the amount of material we need in our buildings. I won't go into it in detail, but this is a graph that tries to summarize part of a design process for a building. You will have to decide what kind of systems you put into your building. You've got a choice across the bottom for cooling your building. It's very interesting when you then look at how much is for cooling what happens inside the building and how much is it for cooling the solar gain, for example. You then start looking at smart technologies and how they can change what happens in the building. And you then start looking at which of the smart facades to use. And lo and behold, bottom left, you start ending up with a whole new ball game of alternatives for looking at servicing buildings with a lot less resource. A lot of them is actually understanding how nature works, because it can absorb heat and cooling processes naturally. But actually, very often we get scared that a block of material which absorbs heat when there's excess, and then when there's temperature drops later, will automatically feed it back. We're struggling because there isn't a bit of electronics in it. But how do we key that in to the smart bits where people want that fingertip control of other aspects of the building? So the idea of re-imaging a building and what it stands for, getting rid of a lot of the material which happens in the building, and I'll come back to aspects of that, giving people more control and dramatically reducing the resource is actually an integrated package. It is very difficult for someone to come up with a single innovation and make a lot of money out of it if it doesn't impact and understood by the other components in a building. I would carry this on into master planning. How many people, we heard this morning, I'll just whip through these, we heard about electric vehicles and the benefits. We should be looking for all the benefits, not just a single payback. Did you know that electric vehicles can halve the energy use in buildings? That's it. If you can get rid of that pollution and noise in our urban environment, given the fact that we're heading towards 80% in urban environment, and the UK's probably fairly close to that already. But we have these closed windows, sealed, air-conditioned. Well, if you go air-conditioned, you go deep plan and all the rest of it. We've got so much data which shows once you open the windows, people tolerate wider conditions, they feel in control. The energy use of your building, if you design it like that from the word go, is half what an air-conditioned building is. All because of the electric vehicles. I don't remember that in the total integrated offering of why we ought to be going for it. So how do we put this all together? Bits. There's the desktop IT. We're still designing buildings which need 10 times the energy of that. That's using dense office, 1-2 watts a square meter. We're putting 20-25 watts a square meter. That's the problem we've got in the construction industry. We're still assuming you've got servers in your building. Who uses servers now? Wireless technology has revolutionized what we're doing. And you know what? It's because batteries don't work very well. Because they limit to what they can store. The process people, ARM here in Cambridge, have excelled because they've recognized how processing can be done with so much less energy. You don't need that bloody great fan on the side of your PC to dump all the heat from your processing. That should have an impact on the building. Allow it to be run more passively, for example. Task lighting. We still get requirement, you have to light the whole of your room to a certain specification. Actually, I'm finding I need more light than I used to when I was a youngster on a drawing board, for example. The ability to tailor your lighting levels and actually control it yourself. And what is very interesting is that people are quite happy, in technical terms, with 50 lux of light on their desk, knowing that the moment they switch from the computer to read a piece of paper, they can flick it up and it can go to 350. So why the hell are we designing our buildings so that they're all 350 or more, just in case? The same with lower energy appliances, the idea that this allows us to use more passive systems. And this is where one starts to find interesting things coming about. We are still, as an industry, putting the equivalent of a 4 or 6 litre engine in our car. And people say, well, it's a low energy building, so they're expecting you to work on the throttle, very end of the range. The fact is, if you design your building so it only needs a 1 litre engine, you reduce the capital cost as well as the energy cost. Now, the opportunities of integrating all of these things together with giving people more control of their own environment, daylight quality, not quantity, the IT component, the smart bit, which allows you to get instant feedback of what you're doing. And for the Chinese, the fact they only needed to build a third the number of, dare I say, coal power stations, at least was leading them in the right direction and setting them up for the replacement thereafter. But ultimately, we're an industry driven by capital cost. So the idea of putting all of this together, so you say, look, this is a typical energy use of a building, this is a typical cost, but we can pull it down using so many of these features, the smart technology, the passive technology. We can then start integrating it with the kit that we've taken out of the building. We don't need drop ceilings. We don't need the AC unit above the ceiling. We're just using the concrete slab, which is used for structure as well as fire separation, but also cooling. And then start to couple it together with renewables on the building, which are a revenue earner across the life of the building. You begin to talk about buildings which do not cost more. Indeed, we're now looking at them costing less than business as usual. Slight problem of institutional expectations. I'm expecting a drop ceiling. But this is an example I'm working on at the moment. South London. The key thing to look at here is the top of the building, and there's a double-story plant room at the moment. It's an existing building which is changing from office to residential. What one said is, how about super insulating the outside of your building to passive house standards? Because we can eliminate the central boilers, the central combined heat and power generating energy for you by reducing the demand to start with. Key thing, looking at resource utilization, is we offered them 2 extra floors of apartments in lieu of that central plant. So the investment in getting the building fabric right and reducing the loads meant that we have a single unit in each apartment, which from the exhaust air, which polluted air you take out, generates both your hot water and the modicum of very small amount of space heating you need. Now, these are sorts of examples which we need to use and bring this sort of integration of technology and ideas and innovation together for a fragmented construction industry. I have to say there's a lot of buildings we've built in the last 25 years which you can't upgrade so easily. And you start looking at the long-term availability of materials, and we will lose out on that, and realize actually there's some of these buildings, particularly steel frame ones, for example, where we ought to be considering how do we deconstruct that and produce 3 buildings from the same amount of resource. And this is where you begin to see crossover with some of the things you've heard of earlier on today. If you take the way we currently design buildings, you've got a steel beam, solid steel beam. It's got different loads on it from one end to the other with shear and bending in different places on that beam. But nature doesn't do solid. So if you start looking at how nature does it, you end up with a very different structure. You end up with these labyrinths, and the structure of the labyrinth inside changes its density depending on where the loads are. So there's some interesting ideas now being developed which say, right, we take that steel beam out of the building, which isn't working very well at the moment. We then put it through 3D printing to produce a new beam, bespoke to its position in the new building, because they're all under different loads around the building, so that you can then produce 3 beams from that same beam. You're using the resource we've already taken from nature to harness it to get more value out of it. The lower 2 images are, when I was in Shanghai, a 3D built building, series of buildings in fact. It looks rather like using Colgate toothpaste, but you can see the way it's going, and the fact that the aerospace industry is already being able to work on this sort of technology. We're watching, waiting, and we want the cost to come down, and we've got plenty of use for those kind of technologies. So as a construction industry, recognizing the opportunities and the challenges is an important aspect of identifying where we can feed in the innovation and the different ways of working. Traditionally, it assumed lots of materials and it threw out an awful lot of them out. There was no priority to minimize the amount of material because it was relatively cheap, and that's where we're changing. So look at that building versus that one, and you find the thickness of the slabs, concrete slabs, has shrunk. And post-tension slabs, for example, uses half the concrete. Do we do it? Oh, it's something different. But the idea that we can integrate it with a whole set of other things to give an overall cost benefit to the client is where we need to start thinking. The fact that when we do a room in an office building, we then put an inner enclosure round, a drop ceiling, plasterboard walls, so forth and so on, to cover everything up. We should be thinking about the fact that we've missed the opportunity to make those base materials finished materials. And the interesting thing is, it completely changes your embodied energy equation. Because the bit which have the highest embodied energy in the building are the bits which are stripped out so frequently before the materials have come to their end of the life, because they've got a bit shoddy and what have you. And the tenant changes. Where we could be looking at how do those structural materials, that base-laying enclosure and structure, serve as finishes as well. Institutional standards are incredibly slow to change. But I would say one thing. UK, unlike a lot of countries, we actually have a lot of benefits in our regulations. And this is the opportunity we all have as innovators. Most of them are performance-based, not prescription. They may suggest that if you do this, that, and the other, you will get there. But as long as you can show you can achieve the end goal, the construction industry offers a lot of opportunity for innovation. One of the worries is our end procurers of buildings are pretty superficial in what they look for in a building. Here, apartment, surely you want this beautiful view. Doesn't it look glorious? Oh, I've forgotten to look at what the EPC, the energy label is, or even the square meterage. They sell it on image. The fact that it's a ruddy greenhouse, and you will cook most of the time, and it's actually essential to have full air conditioning to operate it, I'm afraid, somehow goes past the board, slips past. And the worry is a lot of these buildings, certainly when you're looking at commercial buildings in places like Birmingham, London, and so on, are actually seen as a safe deposit box for someone. The value of property holds its price with age and goes up. And the unfortunate thing then is, how do you resolve that with, do they work properly? Do they lower their resource use if people are making money out of it anyway? So we have to be looking at a world where we can build to that quality, but using less cost. And then finally, my final point, we have a very fragmented industry. It's cut and diced, whichever way you look. So you might have at the top of that pyramid a green client and a green design team. But by the time it's been handed down to the project managers, the suppliers, the installers, the subcontractors, they've never looked at your glorious document about how sustainable your project's going to be and all this smart technology you're going to put in. They'll do roughly as they do business as usual, and it's cost and program for them. Now, understanding how you work in that industry has taken a lot of time and thinking, but ultimately it is a cost-driven industry. And it's very intriguing if you're looking at sustainability being reducing materials and volumes of materials, you're looking at potentially reducing the costs. So I conclude. One, yes, there's a mismatch between planet resource and demand, and it's not going to get any easier, and arguably we need to be thinking about that now. Our future prosperity, us as, the money we get as people, as society, we need to be using less material. Is it right that so much of our money, prosperity we do create, ends up in a Russian bank account buying gas, Saudi Arabian bank account buying oil? Surely isn't it better to look at reducing demand, investing in reducing demand, which is done locally, and therefore investing that money back into our own communities? So there are potential to make some very large step changes if one understands the industries and then starts to plug together many of these innovations. So one's looking far more long life, loose fit, passive, rolling with nature, you might say eco-minimalism. But on the back of that, reduce costs. The systemic challenges of fragmented industries, therefore you have to appeal not only to that, I'm solving that problem, but it gives benefits to the other people all around, and then will trickle down as benefits to the implementers on the site. So you must be cross-cutting in the way you're looking at technologies solving problems. The major opportunities are at the interfaces. Being very divided up, you therefore get people who have specialized in their own field. The opportunities between those fields are enormous. And ultimately, it's unlocking that economic driver, which one feels will be the key for the future. Thank you.